Good evening. Tonight we are going to learn about some trigonometric ratios. You can just call them trig ratios for short. Trig ratios are ratios of the side lengths of a right triangle. Okay, so we are just looking at like the length of this side, the length of this side compared to the length of this side. So here's the three that we're going to use in our class. This is pronounced sine. Sine of angle A is the length of the opposite side of the triangle divided by the length of the hypotenuse. So in other words, like if we were looking from angle A, so obviously this vertex is called A, so this here would be angle A. The side that is opposite of this angle would be this one. Okay, this is the opposite side of the triangle. The hypotenuse is always your longest side, so that would be this one. Okay, cosine of A equals adjacent over hypotenuse. Now, if this is opposite to A, and if this is your hypotenuse, this side must be your adjacent side. Adjacent means next to. Now, I know the hypotenuse is also next to this angle, but the hypotenuse is your longest side. So it's the side that is next to this angle that is not the longest side of the triangle is your adjacent side. Tangent of A is the opposite side divided by the adjacent side. So opposite divided by adjacent. Now, I know we're just introducing this concept, okay, but the more you see this, it'll become familiar, and I'm sure you will feel comfortable to use this. This is a little acronym that we can use. We just say SOHCAHTOA. S stands for sine. So what this means is sine equals opposite over hypotenuse. This means cosine equals adjacent over hypotenuse. And this means tangent equals opposite over adjacent. So that's what SOHCAHTOA means. It basically means this. Okay, it's a little acronym to help you remember what sides relate to which ratio. Now, I do want to say, and we're going to see on the next slide too, that it depends on what angle you're looking at. For example, if we were looking from angle B, this would no longer be the opposite side. The opposite side of the triangle to B would be this one. So in red, right, this would be the opposite side to angle B, which would make this one the adjacent side. Obviously, your hypotenuse stays as your hypotenuse. So you have to be aware of which angle you are looking at as to whether the side is opposite or adjacent, because those two can change depending on the angle. Okay, let's have a look at these examples here. So if we look at sine of A, okay, so this is angle A here. Sine means the opposite of A. So opposite of A, or the side that is on the opposite side of the triangle, is 12. The hypotenuse is your longest side, which is 15. So from here we can reduce our fraction, and we're going to get 4/5. This is all we're doing if the question is find the ratios. Okay, this is a ratio. That's all we're doing. Cosine of A is adjacent over hypotenuse. Okay, so if this is opposite, if this is hypotenuse, this must be adjacent. So adjacent is 9, hypotenuse is 15. We can reduce that fraction to become 3/5. Tangent of A is opposite over adjacent. So we've got 12 over 9, which becomes 4/3. So like I said on the previous slide, depending on the angle, right? So if I erase this really quickly, so now we're looking from angle B. From angle B, if we're looking at sine, we're looking for opposite. Opposite of angle B is 9. So we get 9, the hypotenuse is still 15. 9/15 reduces to 3/5. Cosine of B, meaning adjacent, over hypotenuse, which is 12/15. That reduces to 4/5. Tangent of B is opposite, which is 9, over adjacent, which is 12. 9/12 becomes 3/4. Now I want to show you something here, and this is always true. The sine of A, you'll notice, was 4/5, is always equal to the cosine of the opposite angle, right? So sine of A always equals cosine of B. They're the same thing. Cosine of A always equals sine of B. Okay, so you can see those are just kind of the reciprocals of each other. And then finally, tangent of A is the reciprocal of tangent of B. Okay, so that's a relationship that you will always see. Now, what we use these ratios for is to find missing side lengths. So if we have a look at this triangle here, we have this angle in here, which is angle A, right? We have this side here. So you have to determine what side of the triangle this is. So this side is on the opposite side of the triangle to angle 48. This is your longest side, so this is your hypotenuse. So then you ask yourself, which rule, sine, cosine, or tangent, deals with opposite and hypotenuse? And that is sine. So you would write sine. You wouldn't write angle A anymore because we have a measurement. So you would write sine of 48 degrees equals opposite, which is x, over hypotenuse, which is 14. And now we're going to solve this equation for x. So we would multiply both sides by 14. So x is going to equal 14 multiplied by sine of 48 degrees. On a scientific calculator, you can make that calculation, and you should come out as x equals 10.404. Usually you go to 1 or 2 decimal places, but I went to 3 just for that one. Check to make sure you can plug this into a calculator and get the right answer. Okay, number 8. We're starting from this angle right here. So obviously this is our longest side, so this is the hypotenuse. This would be the opposite side over here, which would make this the adjacent side. So now you ask, which rule, sine, cosine, or tangent, uses adjacent and hypotenuse? And that is cosine. So you would say cosine of 35 degrees, remember the degree angle always goes right here, equals adjacent, which is 10, over hypotenuse, which is x. Now we have to do a little bit more work than what we did up here to get x by itself. First, I would multiply both sides by x. So I would have x multiplied by cosine of 35 degrees equals 10. So then I would divide both sides by cosine of 35 degrees to get my answer. So 10 divided by cosine of 35 degrees, if you put that into a calculator, should give you 12.21 if we round to 2 decimal places. This one here, number 9, we are looking from this angle. X is your opposite side. This is your longest side, your hypotenuse, which makes this the adjacent side. So the rule that uses opposite and adjacent is a tangent. So you would say tan of 43 degrees equals opposite, which is x, over adjacent, which is 6. So in this case, we just multiply both sides by 6. So if you plug in 6 multiplied by tan of 43 into a calculator, you should get 5.595 if I round to 3 decimal places. You could probably round that up to 5.6, but just for accuracy, I left it at 3. Okay, so that's the instruction for tonight. Have a great evening, and I will see you tomorrow.